Okay, limit laws. It says here, if the limit of f at x and g at x has both of them have x approaching a, if they both exist, that means let's say this one approaches a and this one approaches b, then the sum of those two functions, when you're doing the limit of sum of the two functions, you can just consider the limit separately. So sum of this will just equal to a plus b. That's what it's saying here. Same with subtraction. Okay, with multiplication, right? So if you have a multiplication to the function, you know that this is equal to a, you can just say this is equal to like ca, right? Because you can just evaluate the limit of f at x first. This works for multiplication as well, right? So this essentially, if you have a multiplication of f at x, g at x, and you take the limit of that, it's just going to equal to a times b. Okay, it works for division as well, and it works for to the power of n as well. So any operation you see here, plus, minus, times by a constant, product, division, and power, okay, you can ignore those operands. You can just take the limit of the functions first and then worry about the operands after. That's what this is saying, right? So for example, if you had a x squared plus x is approaching 1, let's say, then ignore this operand for now. Just do the limit of on the x squared, where the variables are, and the x. Figure out what they're going to approach, which is 1 each, and then add it afterwards. Right? So this is pretty obvious, right? It's pretty intuitive. But this also works for something like this as well. Like if you have a limit x approaches to 2, let's say you have a square root of 2 plus x squared. And what the limit law is saying, even this square root, which is equivalent to the power of 1 over half, right, you can ignore that operand, do the limit of what's inside where the function is, right, which in this case, because it's 2, you can just sort of ignore the 2. If you do limit as x approaches 2 on 2, it's just going to be 2. Right, so you just worry about the limit of this and do the operations afterwards. So this is going to equal to 4, and then do the plus 2 and then do the square root, so we get root of 6. So I hope you understand what I mean by this. Just means do your analysis on where the variables are going, or some functions of the variables are going, and worry about the plus, minus, multiplication, division, and the power operations afterwards. So that would be a quick summary of what limit laws mean for us. For example, this one here, which we did earlier. Okay, so by limit laws, what we can do is, we can just consider the limit of these separately. So you get 2x cubed, limit x approaches to 2. Okay, this is indicating that I'm going to worry about what's happening to these 3 separately and worry about the minus and plus later. Okay, and using this one here, using that one there, you can actually even not worry about this multiplied by 2 until later, after you do the limit. So that means you write like this. This 3 as well, you pull it out, do the limit on the x squared first. Okay, and the limit as x approaches 2 on a constant, it's not going to change the constant, it's just going to be 5. Okay, and then you do the limit, so it's going to be 8 here, right? 2 to the power of 3. X approaches 2, so it's going to be 2 squared 4. Okay, so then we just evaluate that. Now earlier I didn't actually explain this detail, right? But that's what I did initially, essentially, because I replaced x with, right, 2 plus delta. Wherever I saw x, I replaced it with 2 plus delta. That automatically takes care of where the variables are. You know, I'm figuring out exactly what's happening to the x cubed and x squared, and then only after I figure that out, I evaluate everything. So this is doing the same thing. It's going to follow the exact same procedure as the delta method. Right, so it gives you 9. Okay, so hopefully I'm not confusing you here by doing it a little bit differently, what seems to be different. But going from here to here, I skip one step. I essentially skip this, right? I said in the previous example I did 2 plus delta cubed minus 3 2 plus delta squared plus 5. Okay, and then of course that right there, as delta approaches 0, clearly is going to equal to that. Okay, so it's the same thing as what we did before.